My name is André Zenner, and I'm a doctoral researcher at the German Research Center for Artificial Intelligence and Saarland University in Saarbrücken, Germany. In the following, I have the honor to present to you the work of my co-authors Cora Regitz, Antonio Krüger, and me on the subject of blink-suppressed hand redirection. In our paper, we investigate a novel approach to implementing unnoticeable hand redirection, also known as body warping, which has been shown in previous research to enhance proxy-based haptic feedback or the ergonomics of 3D user interactions. Traditional hand redirection techniques, such as sketched in this animation, gradually offset the virtual hand rendering from the user's real hand position to invoke a compensation movement. The compensation of the hand offset affects the real hand trajectory and leads the user's real hand to a dislocated physical target while the virtual hand ends up reaching the virtual target. So far, however, hand redirection research has not yet investigated techniques that make use of change blindness induced by visual suppression, such as during eye blinks. These short moments of temporary blindness, however, have been successfully used to improve redirected walking by covertly injecting manipulations. To start filling this research gap, we propose a first algorithm for blink-suppressed hand redirection, short BSHR. Our algorithm is based on the technique by Cheng and colleagues and is designed to allow for an investigation of the concept's general feasibility and its detectability. Our investigated technique supports two modes of operation. The first mode, called instantaneous BSHR, does not add any hand offset while the user's eyes are opened. When closing the eyes during a blink, however, the complete offset between real and virtual target is added instantaneously to the hand rendering. As the user closes in towards the target with opened eyes, this offset remains constant and no additional warping is applied. The following video demonstrates our implementation of the technique, with the virtual green hand rendering highlighting the real hand location for illustration. The second supported mode of operation mixes the idea of instantaneous offsets injected during a blink and the traditional approach of continuous hand warping. To achieve unnoticeable redirection, here the virtual hand is gradually offset from the real hand location when the user's eyes are opened, but the amount of gradual warping is restricted to a redirection amplitude below detection thresholds. During a blink then, our technique instantaneously changes the hand offset in a way that, when compensated for, enables the user to reach the targets with continued unnoticeable warping. To implement this, the second mode of our algorithm is parameterized. Specifically, the algorithm takes as an input information about how much continuous hand redirection can go unnoticed by the user. This input is provided in our implementation in form of the detection thresholds assessed in our VR 2019 paper, consisting of the maximum unnoticeable redirection angle, as well as the minimum and the maximum unnoticeable gain factors. These parameters are used within our algorithm to estimate an area of unnoticeable redirection, indicated here in red. By raycasting from the virtual towards the physical target against this area, the algorithm determines a dummy target that is used as a destination for the continuous warping. The remaining offset from dummy to physical target is then applied during a blink. The following video showcases our implementation of the second mode. For more details, please refer to our description in the paper. In order to investigate how much hand redirection can go unnoticed with our proposed approaches, we conducted a psychophysical user experiment. By applying an adaptive interleaved staircase method, we derived the detection thresholds of 4 different conditions along 3 representative directions. In the first condition, we evaluated mode number 1, which does not involve any continuous warping. To further conditions, evaluated the second mode of our algorithm, once with very conservative parameters representing only 50% of previously found detection thresholds, and once using 100%. In a baseline condition, we assessed the conventional algorithm of Cheng and colleagues that applies unconstrained continuous warping and does not leverage blink suppression. In our experimental setup, we tracked the participants' calibrated fingertip location, and participants repeatedly reached for a virtual target in VR while different amounts of redirection were applied following the staircase method. Upon touching the virtual target in VR, participants then answered a yes-no question asking if they noticed any manipulation. Summarizing the results, we could prove the practical feasibility of pure blink-suppressed hand redirection as in mode number 1 and found thresholds to be significantly greater than 0 centimeters and generally of the same order of magnitude as the thresholds found for conventional approaches. The results of the rightwards and downwards direction of mode number 2 indicate that when combining instantaneous hand shifts during blinks and continuous warping below detection thresholds, the range of unnoticeable hand redirection can be increased. Finally, our analysis revealed the previously unknown detection thresholds of the popular baseline redirection technique by Chang and colleagues. While our results show blink-suppressed hand redirection to be a promising technique that merits further exploration, we like to note that the algorithm as proposed in our paper still only works under certain assumptions, as it requires users to blink during the reach and before the hand enters the visual focus area. To derive a universally applicable technique, we like to explore how mechanisms can be integrated that ensure correct redirection even if no valid blink occurs, or unobtrusively trigger blinks on demand. Finally, we aim to evolve our technique to also leverage saccadic suppression. For more details about our approach and evaluation, please refer to our paper. Thank you.